That's right.
Hello everyone, welcome back to my channel. In Python programming, there are multiple approaches that we can adopt. For example, our program can follow a procedural approach, where a list of instructions are executed top to bottom, or a functional approach, where the overall problem to be solved is divided into discrete smaller pieces and implemented in the form of separate functions, or object-oriented approach, where we manipulate collections of objects and their attributes. In this tutorial, we will learn about the functional approach. And by the end of this tutorial, we will be able to create our own user-defined functions in Python and use them. So let's get started. In programming, a function is a reusable block of code that executes a certain functionality only when it is called. The key point I want you to understand at this time is the part that says reusable code that executes only when called. You can define functions, but the code within it won't be executed if we don't call the functions to use them. This is different from the sequential execution of statements that we are familiar with. So where do the functions come from? Well, functions come in the form of numerous built-in methods and functions, like print statements that are an integral part of Python and are always available without any additional effort on behalf of the programmer. A lot of very useful functions are available in a number of modules installed together with Python, or packages that can later be installed. We can write our own functions, place them inside our code, and use them. We can also write our own classes with attributes or methods and use them. As explained earlier, in this tutorial we focus on how to create our own user-defined functions and how to use them. So let's talk about syntax to define a function. In Python, a function is defined using a def keyword, followed by a function name that uniquely identifies the function. The naming convention for function in Python follows the same rules as that of identifiers or variables. And then we add parentheses. We can also define 0 or more parameters inside these parentheses that become the input variable to the function. A semicolon marks the end of the function header as well as the beginning of the code block within every function. The first statement of a function can be an optional statement called the documentation string of the function, or Docstring for short, to describe what the function does. There can be one or more statements within the function body. Statements within the function body must follow same indentation level, usually with a tab or void spaces. An optional return statement, if present, will return an output value from the function. If return statement is not included, the function will return none. Function ends where the nesting ends. The main body of the program begins below the function definition, usually after 2 line breaks in between. If we need to use the function, we can do so by simply calling the function name in our code and assigning a value to the parameters, followed by any further program statements. Later, when we execute an example program, I will show you how the control flow jumps back and forth when the execution encounters a function. But before that, let's see some advantages of using a function. The most practical benefit of functional programming is that it allows us to break apart our problem into smaller pieces. As a result, programs are more modular. This allows sharing the program responsibility among many developers. It's also easier to specify and write small functions that does one thing than a large program that performs a complicated transformation. Often these functions will be used in a wide variety of programs. Over time, you will form a personal library of utilities to the point that you might be able to create new programs by assembling these existing functions with small tweaks or configurations, along with very few new functions for new or additional tasks. Small functions are also easier to read and to check for errors. There are fewer corrections to be made, as only functions that need corrections will be adjusted, with the trust that the rest of the functions will still do their parts. Testing and debugging a functional style program is easier. Because each function is a module that provides certain output for a given input, it is easier to do a rigorous test to prove, or at least get high confidence, that the program produces the right result for all possible inputs. A well-defined function works like a black box that can be viewed in terms of its inputs and outputs. Others should be able to use the function without any knowledge of its internal workings. Before we begin, don't forget to hit the like and subscribe button to get more contents like this. So here I'm going to start with a basic definition of a function using a def keyword. My function name would be display on profile. parentheses. In this case, I don't have any parameters, so I'm going to start with a semicolon that marks the end of the header. And the body, in this case, I'm just going to write a statement, which is a passive statement. So what does a passive statement do? Well, basically, it does nothing. When we run this code, we don't get any error. However, we don't see any output because that's not what the function has been defined to do yet. So this is basic bare bone valid definition of a function. Now we can modify this function to include the docstring, and usually that would be inside triple quote. Anything that I want to put here as help to other users can be input as a string here. No arguments needed, and I'll soon explain what arguments are and what parameters are. So this is the docstring. Now instead of pass, I'll print, in this case, I'll say Bond. The name is James Bond. And let's add another print statement here. This time I'll say I'm agent number 007, and let's do the next line. So now we can run this. We still don't see an output because we actually have never called the function in our program. So we need to invoke or call the function to be able to see the output. So the way we call the function is just repeat the name that we use in the function definition, 2 spaces in between, and then use the name and set of parentheses, and that will be a complete call to that function when the program is run. But just to show you, I want to add a few more lines before and after that. These lines are basically just a print statement. So what's happening in this is I'm basically calling the same function that I defined earlier twice in line number 9 and 10. The program is first instructed to print this statement or a string. Then there's 2 different separate calls for the same function, and then another print statement that prints another string out. And now when we run this again, let's give it a try. Now we see the output from the first print statement, and then 2 outputs from 2 separate calls to the function, and then the last print statement output here. Let's talk about this docstring here. This docstring is used to describe the function that we have defined. The use of docstring in functions is optional, but it is considered a good practice. And that's because if an anonymous user comes across this function and doesn't know what this function does, then he can simply use the help function and pass the function as input their display bone profile. And when we run this, it should give us the display of that docstring here. So the user can now know what the function does and what is the proper way to call or invoke that function. In this case, there's no arguments needed, so just a call to the function without any parameters. Another way to get this docstring output is use the print function. Instead of help, we can do print display bond profile and the attribute dot underscore underscore doc. Run this, it will give us the docstring output. To better understand what happens to the control flow when our program includes user-defined functions, let's go back to the previous example that we had for the display bone profile. We have 2 separate calls to that same function that we defined here. So let's add a breakpoint on line number 1, which is the start of the function definition, and line number 8, which is the start of the main program. And then we're going to run debug test mode. When we run the debug test mode and watch the console output, as well as the control flow, we find that the execution starts at the top as usual. The interpreter recognizes that the first line defines a new function with the def keyword. When we step over or press F8, the control skips the statements within the function and directly jumps to the start of the main body program. Now we step into or press F7 or even F8 to see the next step. The print statement was executed and the output is seen on the console here. And the control moves to the next line of the main body, and it recognizes that the function call has been made. Now when we press F7 again, it goes into the function and goes back to the top of the function definition. Press F7 again, the control moves to the first line inside the function definition, which is the first print statement. F7 again, and we see the output of that print statement on the console, and the execution moves to the next line within the function definition. Another F7 and another print out, and now the end of the function was raised, so the control moves back to the original line where the function call was made. Another F7 at this point, and the control moves to the next line following the previous function call, which is the second instance of the same function call here. F7 again, and therefore the control moves back to the top because of the function call. And then another F7, it goes to the print statement, executes it, and goes to the next line, F7 again and executes that print statement, and the control moves back to the second instance of the function call that was invoked. Now when we do another F7, control moves to the last print statement, one more F7 to print out the end here statement. So I think this better serves to help you understand where the control flow moves when the function call is made and when the function call is defined within the script. We have to keep in mind that function call needs to happen after the function definition has occurred. Let's say I want to put that up here at the top. So I'm calling the function first and then defining the function later. And when I try to run this, it should give me name error because the function is not defined yet. When we define the function, we didn't assign any parameters or arguments to this function. But we can also define functions that takes arguments as well. When a function accepts data provided by the invoker, source data can modify the function's behavior, making it more flexible and dynamic to changing inputs. A function can have as many parameters as you want. Let's see an example function with 2 parameters. I'm going to modify this definition here. So instead of one profile, I'm going to say user profile. Instead of blank within the parentheses, I'm going to pass 2 parameters here. The first is user and the second is age. And this would be function with 2 parameters to display profile for user. I'm gonna just use a single print statement, use a f string to print out these values that were passed as inputs. And that would look something like this. We probably don't need this. To call that, we'll say display user profile. Now we need to pass 2 arguments because the function definition has 2 parameters, user and age. So we pass a name, Amber, in this case, and let's say Amber is 34 years old. And let's give it a run. This is Amber. Amber is 34 years old. That's basically all that the function does. It takes 2 parameters, passes them as values in the statement, and prints out this statement. As I explained earlier, a function can have as many parameters as you want. In this case, there are 2 parameters. Now remember, we haven't restricted age to be any integer values, so it can also be a string value, and when we run this, we will still get the same output. Notice that assigning a value to the parameter is done at the time of the function's invocation by specifying the corresponding arguments. This means that invoking this function needed 2 arguments. The first argument that corresponds to the user parameter and the second argument that corresponds to the parameter age. The way we wrote this is known as positional argument passing, where the meaning of the argument is dictated by its position and not by the name. So the first position would always be user, the second position will always be the age. We can also use keyword argument passing, where the meaning of the argument is dictated by its name and not by the position. So if we do user equals to Amber and age equals to 34, we are explicitly defining the 2 parameters. So Amber is assigned to the user parameter and the argument 34 is assigned to the age parameter. And when we run this, we still get the same output because it's essentially the same thing here. Now, in keyword argument passing, the order of the argument doesn't matter. What that means is we can place the age in front and explicitly define age equals 34 and then user equals to Amber. And then when we run this, it would still be a valid call to the function with those input. Now there's another alternate, positional argument passing mixed with keyword argument passing, where we pass some of the arguments and then explicitly define the other. So something like this. We pass Amber and then explicitly say age equals to 34. Leaving behind just one keyword argument looks a bit weird and sometimes may not make sense as well. So it's up to the judgment of the developer on how he wants to make the function call. The key point to note here is that parameters live inside the function and arguments exist outside the function. So user and age are parameters that are defined within the function and only exist inside the function. But the values Amber and age34 are arguments that exist outside the function and are assigned values for those parameters. When we invoke a parameterized function like this, the arguments act like carriers of values passed to the corresponding parameters. Therefore, parameters and arguments are sometimes used synonymously. Next thing I would like to talk about is avoiding some errors when invoking functions. The first very basic thing that we need to take care is these parameters user and age only exist during the function definition. So if we are to print user, that would raise an error because the user is not defined anywhere outside the function. Also, swapping the values or the argument around will give attribute error or sometimes unexpected results. Order of the positional argument matters when not explicitly assigned. So what that means is we cannot provide the age first and then the name of the user later. And when we try to do this, basically what's happening is the argument 34 is being passed on to parameter user inside the print statement at the point when user.title is being executed. There is no attribute .title for the integer type. So we end up getting integer object has no attribute title. Therefore, when not explicitly assigned, the order of the positional argument matters, and we cannot swap them around like this. We also get type error when passing more positional arguments than needed during function call. So function definition here explicitly says we need 2 arguments to call this function properly. But when we make the call or invoke the function, we actually provide 3 arguments here. And that would result in type error because it takes 2 positional arguments, but 3 were given. Similar is the case when not enough arguments are provided when making the function call, and it's still type error, but the display would be a different message here, missing 1 required positional argument age. So basically we only provided username and age is missing. Notice when we just provide 34, it would take 34 as name and it still say age is missing. But now when we say age equals 34, now we would say username is missing. So keep that in mind. The last type of error that we need to take care of is the positional argument that follows keyword argument. So let's say here we have keyword argument age equals to 34, and then if we try to assign a positional argument, let's say Peter in this case, and try to run this, because username should come before any of these keyword argument, it is spitting out this syntax error saying positional argument follows the keyword argument. The same error will be displayed when we switch this around. In this case, the order is correct, but we are still defining this value before the 34, which is invalid. So that would also give us error output. Next thing I'd like to talk is functions with default parameters. If a particular parameter's values are in use more often than others, we can assign default or predefined values to such parameters when defining the function. Let's add another parameter here saying the status of the user and give it a default definition here, single. Now we have to modify our print statement here based on that. So let's say Peter is 34. We don't explicitly talk about status when we make the function call. Let's give it a try. And it works like a charm, and that's because even if we missed the third argument here, that value for the third argument is already provided as default value, so it's going to just use that default value when the function call is made. Let's update our docstring here. Now we can still use the third argument here and pass the value. The value could be the default value again, and that would be a valid invocation of the function. The value can be empty and it still works, but the output will not be something that we might expect. We can also assign new values here. So in this case, let's say Peter is married, and when we run this, it will show Peter is married. I'm gonna just make multiple calls to this same function with different inputs. So far, the examples we have seen, the functions are not returning anything. It's just spitting out print statements. We can also write functions that return something as output when executed. Now you might be wondering what happens when a function doesn't have a print statement and also doesn't have a return statement. In that case, the function will still return a value, but the value will be non-data type. And to show this, I have a new find distance function defined here. 2 out of 4 parameters have default values of 0, and then the user needs to provide at least 2 values, x1 and y1. With the print statement, here's a function call with the 2 arguments, x1 equals to 3 and y1 equals to 4. And now when we run this program, it's gonna spit out none. Because like I said earlier, this function definition doesn't have a print statement and also doesn't have a return statement. But by default, when there's no return statement, a function will return non-data type. Now to modify this to be able to return something, we can use the distance as a return value. So one way to write that would be say return distance. And now when we run this, we would see 5.0 as output. Or we can simply say return that value and get rid of this statement altogether. And then that would also return the distance that is calculated. Now, since this function has 2 default arguments, we can also provide more arguments, and that would still give us output without any error. So I think that's all for this tutorial video. I hope you learned something new and useful today. If that's the case, please give a big thumbs up. Also, don't forget to share and subscribe to the channel. Until next time, thank you.